Hey class, so we're here with example 4 from chapter 8.5 and it's drawing a scale diagram of a 3D object. So the situation we have is that Celine is an engineer and she's working on a city project replacing old storm sewer pipes with new concrete pipes. Each pipe has an inner diameter of 1.50 meters, a wall thickness of 0.18 meters, and a length of 2.5 meters. How can she create a scale drawing of one of these pipes? So there's a number of things we have to consider. One of them is what are we actually trying to draw this on? So let's assume we're trying to draw it on a piece of paper that's 215 millimeters wide and 280 millimeters long. So this would have been given to you had we given you the problem. So now that we know what we're trying to draw it on, we need to figure out how many perspectives we actually need to see this from. So obviously we need to understand that there are measurements associated with the circle formed here. So we're going to need to look at this thing kind of face on, if you will, and that's what's being represented here. The other thing we're going to have to do is we're going to have to either look at this from a bird's eye view or a left side view or right side view. Because it's a cylinder, they're all going to look the same, and it's going to get the appearance of a rectangle. So this is us either, if you can picture it, looking straight down on top of the cylinder. So now that we have these, we need to figure out a way to determine what's a good scale factor to use. And one way to do that is to consider how much page you have and what you're trying to actually represent in the real world. So for example, in the real life, we know that this diameter is actually the inner diameter, or the 1.5 meters, plus the 0.18 meters. And that would be the same diameter, if you think about it. We're looking down on top of it here, but that would be the same diameter here. So in the actual pipe itself, we have 2 times this measurement that we need to represent in the 280 millimeters. So if I was setting up a ratio, I would set up 280 millimeters has to represent, and if you think about what we have here, we've got 1.68, but we have 1.68 taken twice, so that would be 3.36 meters. And if we change that to millimeters, that actually comes out to be 3,360 millimeters. So this here is giving us kind of our ideal scale factor. Now, if you go ahead and try and figure out our scale factor, recognizing that we're going to be doing a reduction as opposed to an enlargement, I'm going to take my 280 and put it over 3,360. That actually comes out to be 1/12. And so 1/12 is a scale factor that we could use if we wanted to use this entire page. So another comparison you might do is you might look at, okay, I know that this distance in real life is 2.5 meters. So if I take that and multiply it by 100, I would get my centimeters, and then if I multiply that by 10, I would get my millimeters. And so what we find is that 215 millimeters has to represent 2,500 millimeters. And so again, if we try and set up our scale factor, we could set it up as 215 over 2,500. And you can start to factor things down, and what you'll end up finding, you take out a 5 out of here, take a 5 out of here, is you end up getting, I think it's 43 over 500. Okay? So it's 43 500ths, which is relatively close to 40 500ths. And I think you can see how that's the same as 4 over 50, and 4 over 50. If we factored out a 2, we'd end up with 2 over 25, which is really not that far off if you think about it. Divide this through by 2, divide this through by 2, you'd get 1 over 12.5. So you're getting something relatively close to 1/12. So it seems like 1/12 is a pretty decent scale factor for us to use here. What I would caution you about is that you don't want to have your edges of your diagram rubbing right up against the edges of your pages. So instead of using a factor of 1/12, I'm going to shrink this down just a little bit more so it fits on the page better, and we're going to use a scale factor of 1/20. So now all we need to do is we need to take these measurements that we already know. So we've got our 2.5 meters, and we have our 1.68 meters, and we're going to scale all of these measurements down. Maybe we can do them individually. So we've got 1.50, 0.18, and 2.5, and we're using a scale factor of 1/20. So let's do a scale factor of 1/20. So let's start with our 2.5 meters. I'll do my scale factor of 1/20. And if I just take my 2.5, And I think you can see how the net effect is really just going to be taking 2.5 and dividing it by 20. And what I get back is 0.125. So that's 0.125 meters. And then I'm going to take my 1.5 meters and I'll scale that down by the factor of 1/20. So I take my 1.5, I divide that by 20, and I get 0.075. And then the last one I believe was 0.18 was the thickness. And again, scaling that down. So I get my 0.18, and I divide that by 20, and that gives me 0.009. So remember, these measurements are still in meters. If you wanted to convert them to millimeters, you could simply multiply them by 1,000, which is going to have the effect of moving your decimal place 3 places to the right. So all of a sudden, 1, 2, 3 places to the right, we have 125 millimeters. Here we have 1, 2, 3, we'd end up with 75 millimeters for this measurement, and that was the diameter, inner diameter. And then moving this 3 places, we end up with 9 millimeters is the actual thickness of the wall. So in the textbook they did this. I'm not sure if they used the same scale factor as me. And this is the diagram that they came up with. And they said that this was shown to basically 50% of its actual size. Now it seems like if you measured this and doubled it, I guess what they're saying is that you would get the numbers we see right here. But all in all, that's all there is in this chapter. As far as 8.5 goes. So the key ideas that you need is that two 3D objects are similar, have dimensions that are proportional. The scale factor is a ratio of the linear measurement of an object to the corresponding linear measurement of a similar object, where both measurements are expressed using the same units. That's really just saying that, hey, once you can figure out the proportion, you can figure out your scale ratio. To create a scale model or diagram, determine the appropriate scale used based on the dimensions of the original object and the size of the model or diagram that's required. So more or less you're thinking about what am I trying to write this on and what makes my optimum kind of usage. What you need to know is that you can multiply any linear measurement of an object by the scale factor to calculate the corresponding measurement of the similar object. And you can determine the scale factor k used to create a scale model of an object by using the corresponding linear measurements of the object and scale model. So again, this is still saying if you can find the proportion, you know your scale factor. When a scale factor is between 0 and 1, the new object is a reduction. When a scale factor is greater than 1, the new object is an enlargement. And so that's chapter 8.5.